Hey, my name is Howard, and I'm a software engineer at the Autodesk Forma team here in Oslo. And thank you for joining this session. The session will be about scaling your early design workflows using Dynamo as a service for Forma, which we launched at AU last year. So first of all, I'm trying to be very transparent whenever I give presentations. So this is a safe harbor statement saying, please don't spend money based on what I'm about to say. But this presentation is actually quite safe because everything that I'm about to say is clearly public knowledge at this point. So throughout this presentation, I'll start by talking about why I'm excited about this piece of tech and why we pursued building it. I'll describe what it is. And this is a developer conference. And the nature of this is kind of slightly non-techy. So I'll actually dive into some details on how we went about building this. Then I'll give you a short background on the Forma data model, some integral pieces that will help the next session or the next part of this presentation go more smoothly. And then the bulk of this presentation is actually just diving into this and live coding some Dynamo scripts for Forma. So let's consider why. So I'm very passionate about making sharing and consuming code as easy to build, as easy to share, and as easy for the end user to consume as possible. And that's led me to focus on Dynamo, which is a great platform for learning. And within that, I saw that it needs a better way, at least in the context of Forma, for sharing your code and letting your users consume the graphs that you build. So let's consider a journey. You have a user, they have a problem. Maybe they want to figure something out on their site, or maybe they're doing a repetitive task. And you're a developer and you have a suggestion to how they might solve their problem. And probably your suggestion is a piece of code. So now what? How do you go from a problem, an idea, to solving that for the user? So what we really want to get into is an iteration loop where you try to express your solution to the problem in some code. You ship that to the user. Maybe you missed it, probably the first time, and the user talks back to you and says, this wasn't quite right. So you try another time, you ship some code, and the user now says, yeah, that's actually what I wanted. Thank you. Let's go with this. So how do we get this going as fast as possible? So what we're talking about today will allow you as a author of Dynamo graphs to solve this problem in a Dynamo graph quickly with usual tools as you know them. And then at that point, you can drag and drop your solution into the browser and let that Dynamo script run on our infrastructure and for users via the browser. And then you can share this graph on the Forma platform so that your users can consume these graphs without any installs, without knowing that it's actually a Dynamo script running underneath. And this will focus on this iteration loop so that you can go from, oh, I think I know how you can solve this, to your being able to ship this Dynamo graph and the user being able to test it. And maybe the user will say, actually, we're solving the wrong problem. Let's move on. Let's build something else. Or maybe you hit gold and you solved a great user need. Of course, I want you to learn JavaScript and build an extension for your solution after you've validated that this is a great problem to solve. I'm not going to force you to learn JavaScript. Maybe you want to build a server integration for this. But yeah, the main bulk of this is let's validate that you're solving the right solution. Let's talk about infrastructure and performance later. So so this is the motivation of why we're diving into this. But let's back up, because maybe this audience doesn't know what Dynamo is. Maybe you don't know what Forma is, and what's this Dynamo in the cloud that I'm briefly talking about. So let's unpack those first. So Dynamo is a visual programming environment, which is mainly built on top of some sort of host API. So the most famous ones are Revit and Civil 3D. So with Dynamo, you can program in a visual way where you drag and drop nodes and edges and incrementally see the geometry appear in the back and drop. And then really nice property for this is that it's built with a kernel that's potent, so that you can do a lot of geometrical manipulations with it. But it's also built on top of the Revit and Civil 3D APIs. So you're able to pull into the data models of those softwares. And on the other hand, let's look at this thing called Forma that I'm working at. So Forma is a cloud platform and in the long run, a industry cloud for the AEC domain, where you can create your project. You can order the contextual data in the location of the project. You can design how you want to solve the site with ever increasing level of details in the building tools. You can analyze the consequences of different design options on your site with anything from real-time analysis like we're looking at here to more complex analysis running for minutes or hours at our infrastructure. And then you can compare different options, look at the qualities of different options and pick which one solves the site best. And then our most recent addition is a Miro-like whiteboard, where you can tell the story of how you arrived at this way of solving your site. And then let's consider what we built for AU. So Dynamo is a desktop software built on top of mainly Revit. Forma, on the other hand, is a cloud-based browser solution. So these two technologies don't actually compose directly together. So what we did was to move this execution engine of Dynamo to the cloud and connected it to Forma. And the reason why behind this was that we did an initial version of this without the service, and we saw that sharing and consuming these graphs were hard for users, and we wanted to make that easier. So now there's no desktop install requirement on the consuming side. When you want to share your graphs, you don't have to distribute any installers. You can just drag and drop it, and this is really focusing on this part of the problem. Like, you have a solution to the problem, you want to share that problem with the user. Sorry, I'm a developer. I can't really help you talking to your users. You need to consult with someone else on that part. That's maybe harder. So let's look at how this works in practice. So I have a script. On my computer is a dyn file. I drag and drop it into the Forma extension for Dynamo. I click the share button. I remove the warnings, of course. I share this. And at this point, my users can open their projects and open the script that I brought. They can click the run button. They don't have to care or know that this is Dynamo underneath. And we've not focused on performance in this initial launch, but there it is. That's an extruded polygon. So that's the intro to Forma, to Dynamo, and Dynamo as a service. And as I said, this is a developer conference. Let's dig a bit deeper into the technical underpinnings of this. So there are 4 existing parts. So Forma, the design client, exists. It's a browser-based solution. Dynamo running in Revit exists. It's been around for 10 years. We have our Forma API, which is a public version of how you interact with our data models. And then the new thing that we built for AU is running Dynamo as a service in the cloud. And how we built this was as if we were building a Forma extension, as if we were a third party. So anything that you see in this presentation that we've done, you can actually replicate this for your own tools. So our code are based of 2 different code bases. We have a JavaScript or TypeScript-based browser extension or Forma extension running in the browser, the Dynamo player. And then we have a Dynamo package, which is a C# library running as an installed package in the Dynamo environment. And more specifically, this Forma extension runs JavaScript inside of an iframe, inside of the Forma design client. And the design client exposes a SDK, which is a NPM package, which is available to download, which lets the Dynamo player interact with Forma and the 3D scene. And then we have our Dynamo Forma package, which runs in Dynamo, which is talking to this player via HTTP. And it's also talking to the internal Forma API through a layer of the public Autodesk API called APS to interact together. So here you see an example of an extension to Forma, which both runs partly in the browser, partly code on a server on AWS, and also partly on the desktop running inside a desktop software. And there is an interesting aside, which I'll just allude to, is that because Dynamo is running inside of Revit and Civil, the Dynamo Forma package actually lets you integrate Civil 3D with Forma, or Revit with Forma in your own custom way. So here you see Civil 3D, the terrain here actually was pushed from Forma into Civil 3D with the Dynamo Forma package. And you can see here that I drew a alignment in Civil 3D. And in the background here, there's a Dynamo script that extracts this alignment, creates something that Forma will understand, and pushes that alignment as a road back into Forma. Our next topic is sort of like a background material for understanding the next part, which is the live coding part. So this is a crucial part of Forma that you just need to understand as a developer to do anything sensible on top of our APIs. So the grand vision for the Forma industry cloud is that it will be a integration platform that we build experiences on top of, and third parties builds experiences on top of, and all of our desktop applications connect into. And there is one clear part which unlocked all of this, and that is the topic of representations. So in Forma, whenever someone brings their geometry into Forma, they retain their own model and the privacy around that model, and the rest of Forma don't really get to inspect or care about the internal model. So the Revit file, we don't expose that on Forma. What we do is to ask the Revit team to create representations so that the rest of the Forma platform can understand what the Revit model is and what it means. So we have a few sets of these representations, and we're ever expanding these when we see new use cases, and third parties can even add their own if they want to. So you have footprints, which are 2D projections of 3D objects onto the terrain. You have GFA units, which communicates to Forma where your sellable area is located. You have terrain shape, which tells Forma how you want to render your elements onto terrain. You have volume 2.5D, which is a polygon extrusion for buildings with straight walls, which is highly efficient to work with and reason on. And then you have a volume mesh, which is a triangulation of the geometry, so meshes. And then we have an evolution of the volume 2.5D collection, because the volume 2.5D is very convenient, it's very easy, but if you have to reason about what walls are connected to each other, the connectivity, and about the snappiness of points. So is this point actually the same thing? Then we have a bit more involved format for interpreting this kind of geometry, which is called a graph building, which describes the building as a graph instead of just a collection of polygons. And this enables Forma to have a lot of what I call consumers, like our sun analysis or our noise analysis, or even in this case, Dynamo, looking at a lot of different geometry coming from, let's say, Revit or Civil or TestFit or Shapediver or whatever, but they don't actually care what it comes from. They just care about the representations that they express. And the very interesting point here is that no part of this system is important. You can rip anything out and the rest of it stands. And we kind of view the representations as a marketplace where we'll add more representations and the good ones will survive and be used, and the bad ones will die off. All right, so that's all for the introductory material. Let's get to the live coding part of this. So let's reset this proposal. So right now I'm in Forma. And you can see I have set up a site, a building model, and you actually saw my end state where I want to get to within the next 20 or so minutes. But within Forma, we have our extension panel where we can find the Dynamo Forma Beta extension, and we can explore some samples. But for the remainder of this talk, I'll look at actually authoring. So we'll choose the desktop mode. And then I have Dynamo set up over here. We'll clear out this graph, create a new one. Within here, I've added the Dynamo Forma package. it comes in two versions. One is for the 3.0 or 3.x version of Dynamo, and one is for the legacy 2.x version. So if you have, I think, Revit 2023 and below, you need this package. So I've installed this one, and that gives me all of these nodes. I've also added a few other packages, which are also supported on Dynamo as a service. So what we'll do here is, now that I'm connected to my local instance running, I can just open the graph that I just created, and it'll show up with blank inputs. So when we're exploring this package, we're going to start out by looking at selection. That's how you would get geometry from Forma into Dynamo. So we can use the get all elements. I'll just add a few others right now, as we'll need them later. And whenever I add new selection nodes, so inputs, I need to go back to Forma and update this and click the run button in Forma. This is because now I'm pushing new data into Forma. But from now on, I'll be able to work mainly inside of Dynamo. So now you can see that I have a handle to all of the elements inside of my Forma project. And I actually did delete our site limit, because this is the site that we're going to be working at. So I want to re-add that. And now I changed this model, so I'll rerun the graph, and then it'll say 300 elements here soon. Okay, so let's start looking at some of the representations. So the volume mesh would give us the triangulation of each element. And soonish, Dynamo will move to Mesh Toolkit for meshes. So this is not going to give you a Dynamo mesh just yet, but it will probably give you a Mesh Toolkit mesh once it's built in down the line. So if I connect these two nodes to the get all elements, I'll see that Dynamo, which is now running in automatic mode, will start fetching my data. And here I can see the site geometry in Dynamo. Next up, I want to create some data and send that to Forma. So I'll go and select this site limit. So for this, I need a new selection node. Select elements. I'll rename this to site limit right now, so that when I go back here, it's actually going to say site limit. Let's get that selected and run. Now it's here. I mean, this element is actually inside of here, so I can inspect the properties of these elements and then filter it out. But it's also very convenient to just get the user to select these as well. Kind of depends on your use case. Let's figure out in Dynamo where this is located. So let's do the footprint representation. Now, the footprint actually doesn't have elevation, so it will come in below the terrain at 0, 0, 0. But that's fine. So now we want to create some geometry, and the simplest way is this node, which will just eat any geometrical object, curves or solids or meshes, from Dynamo, and just send that to Forma. But we'll start out by looking at the node that is a bit more advanced, that will let us actually create a element with a certain type and some characteristics. There is also a more detailed, like straight off the top of the APIs package, which we will look at after. So what I want to do is to just make like a building constraint envelope here, which is placed on the site and is 10 meters high, so that I know where I'm allowed to build. So I'll go for the elements create by constraint by closed curve and height node. This one needs to know what site, what project to create the element inside. It needs a curve and it needs a height. So we already know that the height should be 10. And then this is the site limit. So we'll just use that as the curve here. I'm going to, for convenience sake, because both the selection node supports multiple elements and each element can have multiple footprints, I'm going to just ask for the first one like this. And at this point, we can see that now the element is created. And this does not mean that it's been added to Forma just yet. It's just that we've now we've created this element, but we've not instantiated it and put it into the proposal that we need to do manually. But it's already an element, so we can actually copy these two like this, and then do this, and that will fetch the volume mesh for this constraint. And then we can see that because we based it off the site limit, which does not have height information, it's actually below the terrain. So let's go ahead and fix that. And we have a nice node to do so. So from the terrain node, we actually have a elevation at node, which takes a elevation and then a XY point. So let's just get an approximation. So let's extract the points from the site limit. So we'll have 4 of those. Let's go for the X value and the Y value of this point. And that should give us 4 elevations at each of these points. Let's just pick the minimum. There we go. And then this is the curve that we're passing in. So let's just go ahead and translate this one up here. And if we then pass this to the closed curve by elevation, hopefully we'll see here. Yeah, the constraint volume is now moved up to the terrain. And then the last part standing is to get this into Forma. And currently the only way to do that is to interact with the player with this node, which takes an arbitrary list of elements and sends them to the player. So with input nodes and with output nodes, we need to go back here. We don't have to update this time because we're not adding new inputs, but we need to rerun it from this side. And then this node shows up. It has like a preview mode like this. And then we can also click and add. And now it's added to the proposal here. And if we were to refetch the elements, we can probably do it right now, then we would see that this count should go to 301. I'm very happy I clicked that button. Yeah, there we go. All right. So now we have our constraint volume in place. The next thing that I want to do is to create a building. I'll just start out by grouping those so that I can remember which ones I need. Like this, we have our site limit, site, but I'm actually starting off with just creating a or a prototypical building, and then we'll place it later. So we can go back here. We can just start by fixing this so I don't have to select it. Yeah, like this. And then what we want to do is to create, I talked about this is a simplistic way of sending stuff to Forma. This is the one level up where you use kind of our built-in stuff. And you can see these are custom nodes. So they are actually built on top of these nodes. So you can go and enter these custom nodes and learn how we've built them. But right now we're going to use a system which is called integrate, which like most of these are kind of opinionated on what representations and what you put into them. But the integration system is not. It's just saying, hey, Forma is this thing, give me representations and elements. I'll eat anything, whatever you want. And that's the one that we're going to use right now. So the first thing that we want to do is to give it a volume mesh. And then we have this node over here, which lets us create a volume mesh from a solid or a mesh. So we'll go ahead and do a rectangle. Let's see, there you are. I'll just give it 10 by 20 meters, or let's go by 5 by 7.5, like this. And then we need to extrude this as a solid. Let's go for a 3 story 2.4 height, like this. It's nice. And then we can create a mesh, and every node needs to know what site we're at. And then we can just drop in this into the representations. So now we see that we have our element. I want to inspect this in Forma, so I'll go ahead and send that to Forma. Go back here and run it. Let's see, there we go. So now it's just located at the 0, 0, 0 point, but we're just playing around still. So I can go ahead and add that, and then I'll see that it'll show up in the generic section. So that's not what I want. And if I look here, there's no area calculated for this thing. So that's two things to fix. So the first thing is to get the layers correctly, we need to set the category on the property of the element. So category building. So if I do this, I'll get a new element. And we can go ahead and rerun this from Forma because I want to add it to the Forma site. And if I add it now, it shows up under the buildings category. So that's perfect. But we still don't have area metrics. And the way to get area metrics is that we need to tell Forma about these GFA representations. So first of all, we need to change the inputs of this to be a list because we're not just going with a volume mesh. So we'll give that a list. And then we need to create, essentially we need to create this one. but this is just a collection of polygons. So if we connect up these like this, and the most simplistic would be to just take like the base of the building like this, and that should give us the base as a GFA. So if I add this now, you can see that it's starting to calculate the areas, and if I hover, it'll actually show the area. But I want this to be a 3-story building. So that's why these two work in symbiosis, because we need one representation of each kind per element, but inside this we can add more. So the simplest way is to just translate the rectangle here, and then add a 0 elevation, a 2.4 elevation, a 2 times 2.4 elevation, like this. You can see in Dynamo that this looks appropriate. So let's go back here. We'll delete the original element. We'll rerun the graph, and there we have it. Let's add it. And now you can see that it has one section per floor. The nice thing now is that I can actually go in and edit this as a 3D sketch element, and it will understand that there are 3 floors here. And even if you add multiple GFA units on the same elevation, it'll pick up that you're doing a floor plan. So the floor planning tool inside Forma will start working. So let's just change this slightly to add a roof to it. I'll exit out of this, and now you see these remain the same. I'll actually go in here and modify the floor plan of the top floor, and add a core to it. Let's see. So I'll change this one to a core. Oh yeah, I modified all that, but that's okay. So now you can see that the BTA is slightly less than the B array because it's not counting this core. So the next thing that I want to do now with this building is to use it and position it on my site. So I'm going to add a new selection element and say building. Yeah, almost. Cool. So let's update this because I added a new input. I want the site limit now, and the site limit is over here. So let's select this one for a site limit, and let's select the building. We'll run it to populate Dynamo. Let's see. Yep, there we go. Let's go for the first one of this and the first one of the site limit. Let's get the footprint site limit going. Let's center for Dynamo on this. So cool. So here is where my novice Dynamo skills, I'm not really a Dynamo developer, will show, but I want to just add something here. So we'll just do a very simple algorithm. I'll first extrude this as a solid so that I can get a center point. There's probably a better way to do this. So there we have a point here. Cool. And I just want to do like a grid motion here. So we'll translate this point. We'll do -20, +20, and then a 10-meter distance between. Oh, this should be inside of a range. Let's see, we'll do this and then add that to the X and Y. We need to make the lacing on this node cross product so that we get all of those points. Nice. So with this, we have our latest addition, which is the set transform, which can take an element and then a coordinate system, which we can create by this one, and then position out the elements on this coordinate system. So here we should have 25 elements positioned. And let's just do the volume mesh of these. And I believe that the volume mesh is actually not located on the elements. So I first need to get all of the children's of this. And then, sorry, this takes a bit of time. So I should have prepared some pause music for this. There we go. Let's put that into the vertices and indices. And let's hide these. No, hide these so that we don't see the point. So now we have put our geometry on the scene. Cool. You can do rotations or scaling with these transforms as well. But we're not going to do that. We're just going to, again, fix the problem of these not being on the terrain. So let's just do X and Y on the geometry. Let's get the elevation at these locations. And then let's translate them. This one like this, and then this needs the terrain. Yep. Again, it's going to take a bit of compute to create all of these elements and download the geometry. There we go. Okay, so now this should be located at the terrain. And let's send them back to Forma. Run the graph here. Yep. And then we can add those like that. Perfect. So the next thing that we want to do is to look at the GFA units that we created. So let's start off by just deleting the prototype building that we created for ourselves. And then we let's just misuse this building node for now. So now we have selected all of these elements. So we can go for get all children of those, and then we can look at the GFA units. And that'll give us all curves for all of the GFA polygons that we created with metadata. So here we can see all of those. So we can, for example, if we make sure to flatten, whoops, not splines, flatten this list, we have a format that's a bit easier to work with. And we can say, I want to look at the areas that are core. I want to filter out the curves that match this mask, and I want to visualize those. And then we have all of the cores. We can calculate areas if we want to. We can change this to living units. If we want to look at living units, we can compose those with functions, can create our own functions, and calculate basically what we want. Maybe we want to apply some offsets to certain area types or factors like that. So the last thing I want to look at now is to run a sun analysis on this site. So we do have this node called run sun analysis. And for it, we need the site, but we also need the root URN of the proposal. So I'm going to cheat a bit here because I know that the first item of the get all elements node is actually the proposal element. I need its URN, which is one way of identifying a element in Forma. So this is like the root URN is for the proposal containing all of the elements. And then I need to give it the paths to all of the elements that I want an analysis on. And I want to run that on our site limit. And the path is the other than URN way of identifying elements. And those are things that are relative to something else. So I'm pointing to the site limit inside of this proposal with this path. There we go. And then we can say, let's do 6, the 12th, like that. And this will kick off a Forma sun analysis. Let's see, it's not that slow. There we go. So from here, we can do a bunch of things, but what I'm going to do right now is to run this function, which will translate the outputs into numbers of sun hours, and the default intervals here are just the whole day from 0 to 24. From the sun hours, we can do, we'll do a small scaling first, and then we'll do colors from a range. I'll just keep them default. We'll do from pixels to create an image of that, and we'll do a watch image. And there we have the sun analysis on geometry created by Dynamo. Sun analysis triggered in Dynamo and analyzes results on the ground, ready for you to consume and do stuff with in Dynamo. So that's about it. So if we go back here and review. So first of all, we've looked at why and how we've moved Dynamo into the cloud and connected that to Forma through building a third-party extension for Dynamo. The JavaScript, TypeScript part is open source already. I'm working hard to get the C# part of this also open source so that any third parties can just fork that and go. We've looked at the Forma package, which lives inside of Dynamo. We've looked at the representations, which are core to the Forma data model. And we've shown how you as a developer can take a problem from a user, turn that into code, and ship it immediately on the Forma platform so that you can get valuable feedback early to figure out if you're solving a good problem, if you have a good solution to that problem, or if you need to iterate, because always you have to iterate. So thank you.